Welcome. In this video, I'd like to show you some examples of factoring method. Factoring is the process to change an expression in product form. For example, 12 can be expressed as 3 times 4, or it could be 2 times 6, and so on. Each of the 3 or 4 is called a factor. In another example, x squared plus 5x plus 6 can be expressed as bracket x plus 2 times bracket x plus 3, and the binomial of x plus 2 or x plus 3 is called the factor. The original expression is called the expanded form. Let's start with the common factor. The common factor is the same quantity in each term of an expression. Let's start by looking at an example. First, we need to check the number of terms. These terms are separated by plus or minus sign. As we can see, there are 2 terms in this question. Let's try to examine the factors in each term. Now we can find the common factors for both terms. The common factors are 2xy. Take the 2xy out from each term, which means that we divide each term by 2xy. We are left with 2x squared for the first term plus 3y for the second term. We can also check our answer by multiplying 2xy into the inside of the bracket to get back to the original expression. The original expression is in expanded form, and the right side is called a factored form. Next, let's look at factoring using identities. Here's a list of some of them. Let's look at some of these identities. First, use a difference of 2 squareds. For any type of expressions, we need to check for common factors. In this question, we do not see any. The first term, 25x squared, is 5x squared, and the second is 2y squared. Now, let's write 2 sets of brackets to have a factored form. For the left part of each bracket, write this as 5x and write 2y for the right parts of each bracket. Then, place a plus sign in one bracket and minus sign for the other bracket to complete factoring. So the answer should be bracket 5x plus 2y, bracket 5x minus 2y. Let's check our answer by expanding the brackets. If we simplify the result, we get back the original expression, which means that we have the correct factored form. Let's move on to the different type of identities, which is called perfect square trinomials. Again, for any type of questions, we need to first check for common factors. We can see the common factor is 4 in each term. Let's take the common factor 4 out from each term, which means we divide each term by 4. And we are left with 4a squared minus 4ab plus b squared inside the bracket. Since we can see that the first and the last terms are in the squared forms, the expression most likely has the form of a perfect square trinomial. The first term, 4a squared, is 2a squared, and the last is b squared. To make sure the middle term of 2ab form, 2 times left term multiplied by the right term, which becomes 4ab. That is exactly the middle term. So this is a perfect square trinomial. Now let's place a bracket to have a perfect square form. Do not forget to keep the common factor 4 in front of the bracket. For the left part of the bracket, we write 2a. Keep the negative sign and write b for the right part of the bracket. So the answer should be 4 bracket 2a minus b to the squared. Let's check our answer again by expanding. Simplifying the result, we get the original expression. Let's move on to another type of identities, which is called sum or difference of two cubes. Again, we need to check for common factors first, which we do not see any in this question. Since we can see that the first and the last terms are in cubed forms, the expression most likely has the form of the sum of two cubes. The first term is 3x cubed, and the other is 2 cubed. Let's apply the right side of the formula. For the first bracket, place 3x plus 2, and for the other bracket, place 3x squared, which is 9x squared, as the first term. Make sure to use the negative sign before the product of the two factors for the middle term. Then for the last term, make sure to use the plus sign and write 2 squared, which is plus 4. Now we have the factored form. Let's explore the next technique, which is called the grouping method. This method is useful when the expression to be factored has 4 or more terms. We can break it into smaller groups with a common factor. Like before, we begin this question by first checking for common factors. However, we do not see any common factors here. Then rearrange the terms in descending exponent order. Divide the entire expression into 2 groups and pull out the common factor from each group. For the first group, we can see x squared as a common factor. Take x squared from each term. We are left with x minus 2 inside of the bracket. Similarly, for the second group, we can see 7 as a common factor. Take 7 from each group. We are left with x minus 2 inside of the bracket. Now we can see the binomial x minus 2 as a common factor for the 2 groups. So take the common factor x minus 2 from each group. We are left with x squared plus 7 inside of the bracket. Let's check our answer by expanding. We get the original expression, therefore this is the factored form. Let's look at another type of questions, which is called Quadratic Trinomials. The leading coefficient is 1 in this case. As with any type of questions, we need to first check for common factors. No common factors can be found in this question. Write two sets of brackets with x. Then we need to find two numerical values p and q such that the product of those equals the constant c, and the sum of those should be the coefficient of x, b. In this case, the product pq is plus 5, and try to find p plus q equal negative 6. First, try to find the factors of 5. Since the sign is positive, both numbers must have the same sign. Try 1 times 5, which gives the sum of positive 6. That is not our desired sum. Then we can try negative 1 times negative 5, which gives us negative 6. This value matches the coefficient of x. To illustrate this process, we tried two cases. However, we know the sum must be negative, so only one combination should have been considered in this scenario. Let's place each value inside of each bracket to complete the factoring process. The order of each factor could be reversed, of course. Let's look at another example for quadratic trinomials. First, we need to check for any common factors. We can see the common factor 2 in each term. Let's take the common factor 2 out from each term. We are left with x squared minus x minus 6 inside the bracket. Write two sets of brackets with x by keeping the common factor 2 in front. Then we need to find two numerical values p and q such that the product of those equals the constant c, and the sum of those should be the coefficient of x, b. In this case, the product pq should be negative 6, and try to find p plus q equal negative 1. First, try to find the factors of negative 6. Since the sign is negative, one number must be positive and the other must be negative. And if you look at the sign of the middle term, it is also negative. That tells us the negative sign with a larger quantity of p or q. Try 1 times negative 6, which gives us the sum of negative 5. That is not our desired sum. We do not need to try negative 1 times positive 6, since this combination gives us the positive sum. Then try 2 times negative 3, which gives us our desired sum, negative 1. Let's place each value inside of each bracket to complete our factoring process. Do not forget to keep the common factor in front. Now let's move on to the general case of quadratic trinomials. In this topic, I will show you how to factor these using two methods, grouping and cross method. First, we begin by introducing the grouping method. Step 1. Find two factors of A, C that add to give B. Step 2. Split the middle term into two terms using the numbers found in Step 1. Step 3, group the 4 terms into 2 pairs. Step 4, factor out the common binomial. Let's look at the first example using the grouping method. Again, we begin by checking for any common factors. However, we do not see any. With this method, we'll find factors of the product of coefficients A and C. The product is negative 60 in this case. Keep in mind that one of the numbers must be negative. We then find the combination of 2 factors so that their sum matches with the coefficient of x, which is 11. Since the sum is positive, we use the positive sign with a larger quantity of the 2 factors. Here is a combination list for the factors of negative 60 with larger positive values. The combination like negative 1 and 60 gives us large sum, so we won't skip such combinations. Let's try negative 3 times 20. Their sum is 17, not 11, so this will not work. We do not need to try positive 3 times negative 20, since it gives us the negative sum. Then try negative 4 times 15, which is the sum of 11. Now we have found the 2 factors whose product is negative 60 and whose sum is 11. Next, we split the middle term 11x into 2 terms using the numbers negative 4 and 15. So write plus 15x minus 4x instead of 11x. Then divide the entire expression into 2 groups and plot the common factor from each group. For the first group, we can see 3x as a common factor. Take 3x from each term. We are left with x plus 5 inside of the bracket. Similarly, for the second group, we can see negative 4 as a common factor. Take that from each term. We are left with x plus 5 inside of the bracket. Now we can see the binomial x plus 5 as the common factor for the 2 groups. So take the common factor x plus 5 from each group. We are left with 3x minus 4 inside the bracket. We now have the factored form. You can also check your answer. Let's try to factor the same question by cross method next. First, think about the factors of 3x squared. And place each factor x and 3x underneath as shown. The order could be 3x on top and x bottom. Next, move to the last term. Find the factors of negative 20. Since the sign of those product should be negative, either one should be negative like listed. Since 1 and 20 combination gives us a big difference, we first try negative 2 and 10. Then we cross multiply to get negative 6x and 10x. The sum of those must be positive 11x in the middle term. However, we get 4x with this combination instead of 11x. Next, let's try switching the order of factors. Unfortunately, we get the sum of 28x this time. We can try negative 4 and 5 combination next. But the sum of the cross multiplication is negative 7x, not our desired value 11x. Let's try switching the order of factors then. The sum of the cross multiplication becomes 11x, which matches with the middle term. Place each bracket top and bottom to get the fractal form. So the answer is bracket x plus 5 times bracket 3x minus 4, which is the same result as the previous method. Let's look at another example. First, we will solve this problem using the grouping method again. As before, we begin this question by first checking for common factors. We can see the common factor 5 in each term. Let's take the common factor 5 out from each term. We are left with 9x squared minus 12x plus 4 inside the bracket. In this method, we'll find factors of the product of coefficient a and c. The product is positive 36 in this case. Both numbers must be the same sign. Then find the combination of two factors so that their sum matches with the coefficient of x, which is negative 12, which tells us both numbers must be negative. Here is a combination list for the factors of 36 with both negative values. The combination like negative 1 and a negative 36 gives us a large negative sum, so we won't skip such combinations. Let's try negative 3 times negative 12. Their sum is negative 15 and not negative 12, so we cannot use them. Then try negative 4 times negative 9. The sum is negative 13. It won't work either. How about the negative 6 times negative 6? The sum is negative 12. Now we have found the two factors whose product is positive 36 and whose sum is negative 12. Next, we split the middle term negative 12x into two terms using the numbers negative 6 and negative 6. So write the negative 6x minus 6x instead of negative 12x. Then divide the entire expression into two groups and pull out a common factor from each group. Do not forget to keep the common factor 5 in front. For the first group, we can see 3x as a common factor. Take 3x from each term. We are left with 3x minus 2 inside the bracket. Similarly, for the second group, we can see negative 2 as a common factor. Take that from each term. We are left with 3x minus 2 inside the bracket. Now we can see the binomial 3x minus 2 as a common factor for the two groups. So take that common factor 3x minus 2 from each group. We are left with 3x minus 2 inside the bracket. Since we see the same factor twice, make it in perfect square form as the final answer. Also, keep in mind that for this question, if you can notice the perfect square from the beginning, it is much better. However, you can still factor with this factoring method even if you did not notice it. Let's try to factor this same question, but with the cross method instead. Previously, we found a common factor, so we need to rewrite the question in that form first. First, think about the factors of 9x squared. The combination of each coefficient could be 1 times 9 or 3 times 3. First try x times 9x for that part. Next, move to the last term. Find the factors of positive 4. Since the sign of the middle term is negative, both factors must be negative as the coefficient of the middle term is the sum of the cross multiplication. So it can be either of two combinations as listed. Let's try -1 and -4 first. Then we cross multiply to get the -9x and -4x. The sum of those must be -12x in the middle term. However, we get the -13x with this combination. Let's try switching the order of factors then. But we get the sum of -37x this time. Let's try -2 and -2 combination next. However, the sum of the cross multiplication is -20x. This is still not our desired value, -12x. Let's try 3x and 3x combination for the factors of 9x squared this time. The sum of cross multiplication becomes -12x, which matches with the middle term. Place each bracket top and bottom to get the factored form. As you can see, the answer shown here is the same as the one obtained with the previous method. If you can identify the correct type you are dealing with in each formula, then your work becomes more efficient and quicker. However, even if you do not recognize each formula, you can still try the standard technique such as cross method. Please try many questions after watching this video. Thank you for watching. See you again.